Okay, so um, quantum computing and cryptocurrencies, right? It seems like people are saying this is going to be like a huge problem.
Yeah, I mean, it is a pretty big deal when you think about what quantum computers could do, to encryption.
Yeah, that's what I mean. Like everyone's saying it could like break all the codes and then like everyone's Bitcoin is gone or something.
It's not quite that simple, but yeah, the potential is there for some pretty serious disruption.
Okay, well, I guess that's why we're here, right? To like break this down.
Exactly.
So, first things first, like what even is quantum computing? Like, is it just like a faster computer or what?
It's a totally different way of processing information. Like our regular computers use bits, which are like a 1 or a 0, right?
Wait, on or off?
Exactly. But quantum computers use these things called qubits.
Okay, and those are the ones that are like both at the same time, right?
Yeah.
That's always so weird to me.
Yeah, it's called superposition. It's a quantum phenomenon that lets them do calculations in a completely different way.
So, like, instead of just being a 1 or a 0, they can be both.
Kind of. It's more like they explore all the possibilities at the same time.
Okay, so that's where the speed comes from, I guess.
Exactly. For certain problems, they can be exponentially faster.
So how much faster are we talking here? Like, give me a comparison.
Imagine trying to find, like, a specific grain of sand on a beach.
Okay.
A normal computer would have to look at each one individually.
Yeah, one by one.
Right. But a quantum computer could, in a sense, look at all of them at the same time.
Whoa, okay, that's a pretty big difference.
Yeah, it's a whole different ballgame.
So, okay, that's quantum computing, but how does this tie into cryptocurrency?
Well, most cryptocurrencies use some pretty complex math problems to secure transactions in wallets.
We're all about that encryption.
Exactly. And for a normal computer to break that encryption would take, like, years, maybe even centuries.
What a quantum computer could do it like way faster.
Yeah, much faster.
Okay, so then what happens? Like if someone builds a powerful enough quantum computer, could they just like steal everyone's crypto?
It's not impossible. If you can break the encryption, you could potentially access someone's private keys.
And that's like the keys to the kingdom, right?
Pretty much. It's like having the master key to their digital vault.
So, okay, that's scary enough, but it's not just about stealing crypto, right? Like, what about the whole blockchain thing?
Right. The blockchain relies on cryptography for its security, too.
So someone could, like, mess with that, too?
Potentially, yeah. Imagine being able to rewrite the transaction history or even control the creation of new coins.
That would undermine the whole point of blockchain, wouldn't it?
Exactly. It would throw the whole idea of decentralization and tamper-proof records out the window.
So we're talking about a potential collapse of the entire system.
The stakes are incredibly high. Billions of dollars could be lost, and not just in cryptocurrency. Any system that relies on public key cryptography could be vulnerable.
So like all our online banking and stuff too?
Exactly. It's a much bigger issue than just crypto.
Okay, so this is not good, but are we talking about something that could happen like tomorrow? Or is this like a far-off future problem?
Well, large-scale crypto cracking quantum computers don't exist yet, but the technology is moving really fast.
Really fast? Like how fast are we talking?
Companies like IBM are making major breakthroughs. We're seeing quantum computers with more and more qubits every year.
And those qubits are what make them so powerful, right?
Exactly. And some experts think that even these noisy quantum computers, ones that are prone to errors, could still outperform classical computers for certain tasks.
So it's not a matter of if, but when.
Pretty much. And the question is, are we prepared?
Okay, well, that's what I want to know. Like, is there anything we can do about this, or are we just sitting ducks waiting for the quantum apocalypse?
There's a lot of work being done on what's called quantum-resistant cryptography.
Quantum-resistant cryptography. So that's like new encryption that quantum computers can't break.
Exactly. It's a whole new field of cryptography that's specifically designed to withstand attacks from both classical and quantum computers.
Okay, so like a shield against this quantum weapon.
You could think of it that way.
So are people actually working on this stuff?
Oh, yeah, absolutely. Organizations like NIST, the National Institute of Standards and Technology, they're actually running a competition to find the best quantum-resistant algorithms.
A competition. So like all the best cryptographers in the world are battling it out to see who can build the best quantum-proof code.
That's a pretty good summary.
That's pretty cool, actually. So we've got these new algorithms being developed, but what about the cryptocurrencies themselves? Like, are there any that are already built to be quantum resistant?
There are a few projects out there that are focused on, this one example is quantum resistant ledger, or QRL.
QRL, so that's like a cryptocurrency that's designed from the ground up to be quantum proof.
You could say that it uses a different type of digital signature scheme that's supposed to be resistant to the kinds of attacks that quantum computers could do.
Interesting. So it's not just about waiting for these new algorithms to be ready. There are already some options out there.
Exactly, and there are others too, like Bitcoin, post-quantum, or BPQ.
BPQ, right? So is that another quantum-resistant cryptocurrency?
Yeah, it's basically a modified version of Bitcoin, but with added features to make it resistant to quantum attacks.
So there are actually people out there taking this seriously.
Oh yeah, there's a whole community of developers and researchers working on this problem.
That's good to hear. It sounds like there's hope then.
I think so. It's a rapidly evolving field, and there's a lot of innovation happening.
Well, this is all pretty mind-blowing. It's a lot to take in.
I know it's a complex topic, but it's important to understand the potential impact of this technology.
Absolutely. So for those of us who are already invested in crypto or thinking about getting involved, what can we do to protect ourselves in this quantum future?
Well, there are a few strategies that can help mitigate the risks, but I think we should save that discussion for our next segment.
Okay, good point. We've covered a lot of ground already.
We have. It's been a great discussion so far.
Yeah, this is fascinating stuff.
Huh?
I'm definitely going to be thinking about this a lot more now.
Me too. It's something we all need to be aware of.
Well, thanks for breaking it down for us. I can't wait to dive into those strategies in the next part.
Looking forward to it. So we were talking about quantum-resistant cryptography, like what's actually being done to develop these new algorithms.
Yeah, it sounds like a pretty big task. Are they trying to create some kind of quantum-proof code that can protect everything?
Well, organizations like NIST, they're leading the charge. They've been running a competition for years now to evaluate potential algorithms.
Oh, yeah, I read about that. It's like a global cryptography showdown, right?
That's one way to put it. They've got cryptographers from all over the world submitting their ideas, and then they put them through all these tests and analysis to see which ones are the strongest.
So survival of the fittest for cryptography algorithms.
Exactly. They've been narrowing down the field over several rounds, and they're getting closer to identifying the most promising candidates.
So what are some of the front runners in this race? What kinds of algorithms are showing promise?
Well, there are a few main categories that are looking pretty good. One is called lattice-based cryptography.
Lattice-based, okay. And what's that all about?
It's based on the difficulty of solving certain math problems that involve these things called lattices. You can think of it like a really complex multi-dimensional grid.
Okay, so a maze, but in a million dimensions or something?
Kind of the idea is that even for a quantum computer, these lattice problems are just too hard to solve in a reasonable amount of time.
So it's like a computational brick wall.
Exactly.
Okay, that's one. What else is there?
Another promising area is called code-based cryptography.
Code-based, okay. And how's that different?
It uses these things called error-correcting codes. It's similar to the technology that's used to make sure data is transmitted correctly, like in telecommunications or even on a CD.
Oh, so it's like trying to read a message that's been scrambled, but there's a secret code to unscramble it.
Yeah, you could think of it that way. The security lies in the difficulty of decoding those error-correcting codes, even with a quantum computer.
Got it. So lattice-based and code-based. Any others?
The third one that's getting a lot of attention is multivariate cryptography.
Multivariate. Okay, that sounds complicated.
It's based on systems of polynomial equations. Think back to algebra class, but on steroids.
So like a math problem that would take a supercomputer years to solve.
More like centuries, even for a quantum computer. The complexity of these equations makes them incredibly difficult to solve.
Okay, so we've got these three contenders: lattice-based, code-based, and multivariate. Are they competing against each other? Or is it more like they'll all work together?
It's likely that a combination of approaches will be used. Each one has its strengths and weaknesses. So by combining them, you can create a more robust defense.
So like a multi-layered security system.
Exactly like building a fortress with multiple walls and moats.
Makes sense, but this is all still in development, right?
Oh, yeah, absolutely. These algorithms still need to be refined and optimized, and then they need to be integrated into existing systems. It's a huge undertaking.
So it's not like we can just flip a switch and everything is quantum-proof?
Not quite. It's going to take time and effort to roll this out.
Okay, so we've got these algorithms in the works, but what about the cryptocurrencies themselves? Are there any that are already using these quantum-resistant features?
Yeah, we talked about quantum-resistant ledger, or QRL, earlier. That one uses a hash-based signature scheme called XMSS.
Right, XMSS, that's the one that's like a one-time password, right?
Yeah.
Each signature can only be used once.
Exactly. That makes it much harder for attackers to exploit any vulnerabilities, even with a quantum computer.
So it's like a preemptive strike against quantum attacks.
You could say that. And QRL is also designed to be pretty lightweight and efficient, which is important for scalability. It's also open source, which means anyone can look at the code and check for any security flaws.
So it's like a community-driven effort to build a truly quantum-resistant cryptocurrency.
That's a good way to describe it. And then there's Bitcoin post-quantum, or BPQ.
Right, BPQ. Remind me how that one works again.
It's basically a fork of the Bitcoin blockchain.
A fork, so like a separate branch of the Bitcoin family tree.
Exactly. They took the original Bitcoin code and added in a bunch of quantum-resistant features.
So it's like taking Bitcoin and giving it a quantum upgrade.
Pretty much it's still under development, but it has the potential to be a major player in the quantum-resistant crypto space.
Interesting. So we've got these new cryptocurrencies like QRL and BPQ that are being built from the ground up to be quantum resistant. And then we've got these new algorithms that are being developed to make existing systems more secure. It sounds like there's a lot of activity in this space.
There is. It's a really dynamic and exciting field right now. There's so much innovation happening.
It's like everyone's trying to stay one step ahead of the quantum computers.
Exactly. It's a race against time in a way.
Well, I'm glad to hear that people are taking this seriously. It's a pretty daunting challenge, but it sounds like there's hope.
I think so. The key is to stay informed and to be proactive about taking steps to protect yourself.
Okay, so that brings us to the big question. What can individuals and businesses actually do to prepare for this quantum future?
There are definitely some things you can do to mitigate the risks, but I think we should dive into those strategies in our next segment.
Okay, good point. We've covered a lot of ground already, but I'm definitely eager to hear what those strategies are. So let's pick up where we left off in the next part.
Okay, so let's talk about what people can actually do to protect themselves, with all this quantum computing stuff coming down the pipeline.
Yeah, like what are some actual steps people can take to make sure their crypto is safe?
Well, the first thing is just to be aware,
Yeah.
right? Like stay informed about what's happening in the world of quantum computing and how it could affect cryptocurrencies.
So like don't just bury your head in the sand and pretend it's not happening.
Exactly. Like this is real, it's coming, and the more you know about it, the better prepared you'll be.
Okay, so stay informed. Any specific tips on how to do that?
Yeah, like read reputable tech publications and websites, keep up with research papers from organizations like NIST, follow industry experts on social media, things like that.
So basically, just be a good little crypto nerd and keep your ear to the ground.
Pretty much the more you know, the better.
Okay, awareness check, what else?
Diversification is key.
The old don't put all your eggs in one basket strategy.
Exactly. Spread your crypto holdings across multiple assets. Don't just go all in on one thing.
And I'm guessing that includes some of these quantum-resistant cryptocurrencies we talked about.
Definitely, as those mature and become more established, it's a good idea to allocate at least a portion of your portfolio to them.
Okay, so diversify, spread the risk. What about security? Like, are there any best practices we should be following?
Absolutely. Multi-signature wallets are a must.
Right, those are the ones where you need multiple keys to authorize a transaction.
Exactly. It adds a whole extra layer of security, which is really important in a world where quantum computers could be a threat.
Okay, multi-sig wallets, got it. And what about cold storage?
Cold storage is essential. Keep those private keys offline on a hardware wallet or even a paper backup.
So like keep your crypto in a vault instead of just leaving it out in the open.
Exactly. It makes it much harder for attackers to get their hands on your assets.
Okay, so we've got diversification, multi-sig wallets, cold storage, anything else?
Yeah, stay on top of software updates for your wallets and any other crypto-related apps you use.
So don't ignore those little update notifications.
Right. Those updates often include important security patches and improvements.
It's like keeping your antivirus software up to date. You always want the latest protection.
Exactly. And of course, be wary of phishing scams and social engineering tactics.
So don't click on any suspicious links and be careful about who you trust online.
Right. Common sense goes a long way.
Well, this has been a really informative deep dive. I feel like I've learned a lot about quantum computing and how it could impact the future of cryptocurrency.
Yeah, it's definitely a complex topic, but it's important to understand the potential risks and opportunities.
Absolutely. It's like we're standing on the edge of a new frontier with all its uncertainties and possibilities.
I like that analogy. It really captures the essence of what we're facing.
Well, I'm excited to see what the future holds, and I'm definitely going to be paying a lot more attention to this whole quantum computing thing from now on.
Me too. It's a game changer for sure.
Well, thanks again for joining us and for sharing your expertise. It's been a real eye-opener.
It's been my pleasure. Always happy to talk about this stuff.
And to our listeners, stay curious, stay informed, and stay ahead of the curve. We'll catch you on the next deep dive.